Welcome everyone to another video, and welcome to all the new viewers and subscribers on the channel. It's nice to see some positive feedback and growth from the SONOS Subwoofer Part 1 video. And in response to that, I have done a lot of work on the bench upgrading some things. We've got this amazing macro setup up and running, which I've been working on in the background for quite a while. Really going to need it for this surface mount work that we need to do on this board. Lots of new tools on the bench, and yeah, we've got a lot to talk about to get started on hopefully bringing this subwoofer back to life. So stay tuned, let's get started. Now I feel like we need to address the elephant in the room, quite literally, before we dive into the parts we're changing and some other tools. So this was what I was originally intending to use. I got this off Marketplace pretty cheap. It's really stout, solid metal, sort of inspection microscope camera. It's quite good. Mount a Canon camera on the top of it and you can get live video from here. Problem is it's only 45 millimeters, so the clearance is really, really short. And the main issue I was sort of playing around with is that the soldering, you're soldering very close to the lens, and I don't really think it's ideal. So I used this as inspiration to build something much larger. Luckily, I am very big into macro photography, and I already had pretty much all the camera equipment, the lights and all that. I just had to build this frame, and this is just built out of aluminium extrusion. It looks pretty fancy, but it was actually really easy to build, and it's quite cheap. And I just mounted my Manfrotto geared head onto the frame, and this is really solid. It can hold a lot of weight, and yeah, it just worked really well. I didn't really have to buy anything other than some video capture stuff, a big charger. These lights are 60 watts a piece, adjustable brightness, adjustable temperature, really nice, soft-ish diffused lights, so we don't get any hard lighting and polarizing issues with the video, as we can see here. Hopefully we get all this right. There's a lot of moving parts in regards to recording all this, and I haven't done it before, so bear with me, and hopefully we get this right. I am planning to do a video deep diving into how I built this, and hopefully people are interested in that. Let me know in the comments. This is a 180 millimeter lens with 3 extension tubes and a Canon R6 camera on this, and I would put this up against any microscope sort of camera setup you could buy off Amazon or whatever. I think it will beat pretty much all of them, especially in low light conditions. The image quality is just fantastic from what I've seen so far. So that's the microscope setup. Let's talk about some other tools I bought just to do this really nitty-gritty surface mount stuff that I haven't really done before. Now, going over some other tools and parts that we got for this repair. So we got some precision tweezers I got off Amazon. These are only like $12 or something. Quite precise, very sharp. I would prefer if they had a bit more grip inside the jaws, but I think they will do the job. So we'll see how they go. I've got an old reel of solder that I had in my drawer. This is a finer gauge, 0.071 millimeters, and I'm only using this because I think it'll just be a bit easier to manage, to not apply too much solder to surface mount stuff, and this is just a much finer gauge, and I think it will be much more suitable. We have some solder wick, #2, I don't know what that means, but it's a 5-25L from Chemtronics. I've used a lot of cheaper soldering wicks in the past, and I've learned to hate solder wick because of it, but I have done some testing with this already in preparation for this video, and I was actually really impressed with how well this stuff works. I guess I've just been using garbage solder wick up till now, and there is actually good stuff out there, so this is hopefully what we're going to use. It's just a finer gauge, again, for surface mount work, to make it a bit easier to handle and get in between components and just clean up those joints. We have flux. So this is from Chipwick SMD LT10. This is an extra tube I bought, so I've got more for the future because I have a feeling I'm going to be doing more surface mount in the future. And we also have Chipwick REM Kit thin. So this is low melt solder, and this is the main key to what is going to let us hopefully rebuild this board. So this solder is very low temperature, about 56 degrees. Even putting the soldering iron near this solder makes it melt. And the idea is that we apply this solder to the components to lower the melting point of the joints. And after that, you should be able to pretty much heat up one leg of the component and all the legs will release because they'll be saturated with this lower temperature solder. And they only give you these crappy little portions, but from my experience so far doing some quick testing with this, it is really impressive and it works without a hot air gun. So we will be using that. It does come with a little tube of flux, which is the same as this one here. And yeah, I'll probably use this one just to use it up because I don't want to open this one until I need it. But this one does have much finer needle tips and everything, so I think this one will be easy to work with overall. This one's sort of just a little squirty bottle. So yeah, that's pretty much all the components we're going to use. I mean, I do have little knife and a few other things. Right, so we have surface mount components. I basically ordered everything that is on that SONOS snapshot that I shared in the previous video. We got that diode. I thought it was a Xena diode, but it's actually a Schottky diode apparently. Some resistors, a few other things. So we got all that. We should have everything, I hope. We'll see, because it's quite expensive to bring stuff over from Mauser. And we also have capacitors. I've ordered all the capacitors that are on the board, and that is basically planning for the future, because if this does work, I would like to recap it while it is open. So these are proper brand name capacitors, not that cap Exxon garbage that's in there at the moment. But those caps are not easy to desolder, being a multi-layer PCB also. So we'll see how we go with that. We need to get it working first before I'm even going to attempt replacing the capacitors. But if we do get it working, we will do this also. So let's stop wasting time. I'm going to switch over to the microscope. First thing we're going to do, I'm going to just take you around a couple of components on the board under a higher magnification so you can see them clearly, show you the measurements, and then we're going to start desoldering things and see how I go replacing them with very little experience. Right, so I thought we'd have a look at a few things quickly just to test my video setup and make sure everything's fine. So as you can see with proper magnification, there is a lot of heat damage around here. These traces have been heated up all the way down to this via, and hopefully this component here is okay. This transistor we're going to be changing, but I didn't order that because I didn't have proper magnification until now, and hopefully this resistor here is okay. Now, some people might just go, oh, that's the problem, it's all blown up and, you know, we just change that and we're good to go. No, this resistor probably blew out because of the diode on the other side that was shorted, leading to excessive current draw, blew this out, blew out another resistor that's off to the left, we'll look at that shortly, and caused all this collateral damage. Resistors don't really fail in a shorted scenario, and usually something else is responsible for this sort of damage. So let's just have a quick look around, make sure that this resistor is okay, and 4.53k, so that one should be fine. This one should be completely blown out, and it is, so we can see the resistance counting up, so it's probably measuring a capacitor in parallel or capacitance in the circuit. I don't know about this transistor, if it's really hard to get a good measurement, if this is likely to be okay. Not reading any dead shorts. Yeah, so potentially it might be okay, but we will change it anyway. One of my main concerns was, where are we? Hand-eye coordination is really difficult doing this. Across this diode. So I just want to make sure that this thing is alive. So we've got voltage drop on that side. That looks fine. No, so that side's not connected, which is what I measured earlier. That may be normal. I just need to double check that. Either that or we've got a damaged side on here, but I think it is normal and it's probably just not connected. And this is the side we're probably concerned about, and we have 0.69 voltage drop. That should be fine. Now, the other resistor we need to have a look at is this little guy here, because this has a giant hole in it, and this is a much larger power resistor. Probably, I don't think it's a shunt resistor, but it's much higher power. This should be 1 ohm. Yeah, this one is no good, as you would expect. So yeah, we'll be changing that out also. Just for everyone's curiosity, we do have some other features with this microscope where we can crop in. So we can hit that, we can get in a fair bit closer, and we also have some digital zoom functions also where we can get in really close without moving everything. I could actually get better image quality by moving the lens closer, but I need some form of field of view so I can look around on the board a little bit. So I'll be operating mostly around this magnification, I think. This is where I found my happy place at the moment. So yeah, that's a look at the damage. We do have that Schottky diode on the other side that was completely shorted that you saw in the previous video. We'll get to that later. But yeah, let's get started removing some components. I think we'll start with this larger resistor because that's probably a good thing to warm up on, and then we'll get stuck into this area. Alrighty, so let's get started with this. I have only had 3 practice runs on another board with this whole process, so we'll see how we go. I am pretty much a novice with surface mount soldering, and this is the new resistor that we're going to be putting in. So this is a 1 ohm 1 watt. I didn't know what wattage this other one was supposed to be, so I got the biggest one I could get my hands on. It looks not exactly the same, but let's just see what happens because it's the biggest one I could find on Mauser. And let's just dive straight in. So first thing I'm going to do is put some flux down on top of what we're working on. Now, I did try without flux just to see what would happen, and I can tell you, you do not want to do that. You will regret everything in your life if you do not put flux down. This stuff tends to stick to everything, including the PCB itself. So yeah, just keep that in mind. Now, we're just going to put some low melt on each side of this component. Doesn't really matter if we put too much on. You can see what I mean. It just wants to go straight up and it will stick to everything. Come on. Might be better just to keep it on the tip, to be honest. There you go. All right, so let's see if we can get this to let go. This is a bit bigger than the other components I've played around with. Hopefully it does. Perfect. Get some braid and we'll clean up the joints. Beautiful. Now I'm going to do something here that I don't know if it's essential or not. I'm going to put down some leaded solder and I'm going to clean it off again because I'm a little bit worried I'm leaving some of that low melt solder on the surface just because it looks really porous. Yeah, it looks about the same. I'm just going to clean the area with a bit of alcohol. Put down a little bit more flux. And we're going to put the new component on. Now, I was really in 2 minds about this, if I should pre-tin one of the pads and then just melt it and stick the part down. I think I'm going to try putting a bit of solder on the tip of my iron because I seem to be able to place parts a little bit better doing it that way. So let's just see what happens. Oh, that is way too much. Jesus. Probably a bit too much there. And then we're going to do the other side. There you go. The OCD part of me really wants to keep playing with this, but I really shouldn't keep heating this component. And I've just noticed this thing is completely cockeyed, so no, I'm not happy with that. How did I do that? All right, I think I'm gonna do this again. Live video. Jesus, this stuff just wants to come off. You don't get depth perception when you're using this microscope, so I did not realize how high up off the board that actually was. I think I'm going to pre-tin one of the pads this time. We'll try it that way. Because it helps just sort of set it in place, but it does make it a little bit hard to position also. Okay, I'm going to tin the left pad just because it's a little bit more accessible. like that. All right, I think I got a better pickup of it this time. I think this is probably the hardest part, to be honest, is just placing the component properly. That's pretty good, actually. I quite like that. Do the other side. I've got to stand up to get the... Actually, you know what? I'm going to start turning the board because angles really matter with this, I've found. Beautiful. All right, I'm going to put a little bit more on the other side just because I like to poke the bear. I think that actually looks pretty good. Clean this up a bit. Yep, I'm happy with that. Okay, so that was a bit of a warm-up round, and we had one boo-boo already. Luckily, we got spare components for everything. So I'm going to sort of speed run the rest of it, and I won't really do much talking because otherwise this video is going to be an hour and a half long probably. And let's just see how we go with the rest of these components. All right, let's keep going with this. Get rid of this old burnt-up resistor. Whoops, I think I put a little bit on the edge of the other resistor. All right, I probably made a mistake here. I should have done this transistor first. I didn't realize this one was actually on the list. I'm hesitant to replace this because I actually did test the other one and it looked fine, but I'm going to do it anyway because why not create more work for myself? I didn't put flux down. I'm an idiot. Stupid. Flux, flux, flux. Small voiceover here. I have no idea what happened to this footage. For some reason my camera must have froze and suddenly it just jumped forward to the component being replaced and everything is missing in the middle. Sorry about that. Everything else should be as normal after this. Alright, just going to get the back side done. We have two components to change. There's this big capacitor here, which is a 1 microfarad. And this one might be a little bit more tricky to get off because it's pretty big. I didn't put flux down. I am on a roll today, I swear to God. And here's your example of what happens when you don't use flux. Why does this stuff just turn to goo all of a sudden? Really weird. There must not be enough solder on there. Alrighty, so I've got everything done. I just thought we'd go over it quickly, just for all the armchair experts who might say I did a horrible job. I think we need some context of what we're working with here. This is my fingertip, okay? So chill. Like this is not easy, and my first attempt at this, doing a board like this, is a bit ridiculous. So I think this larger resistor went quite well on the second attempt, but it is physically larger. I think this one was a MOSFET. Yeah, it's a MOSFET. This one went a bit better. I got the solder distribution, not too much, maybe a little bit on the too much side, but I'm sort of happy with it, so we're okay there. Over here, I'm not super happy. I think there's too much solder on this, and I reflowed this one here. This has got just a bit too much solder also, but I got to stop, you know, cosmetically, it doesn't look great, but when you look at it with the naked eye, it's absolutely tiny, and you're just poking the bear the more you heat up components, because you're risking damaging them from playing around making it look nice. So we'll flip over to the other side of the board, and this was quite surprising. I thought these would be really easy because they're so large, but they do pose their own challenges around heating them up properly, placing them correctly, and this one's just a tiny bit tilted, but I'm just going to leave it. As long as it's soldered cleanly, I'm happy with it. I think this 1 microfarad capacitor was fine, but I decided to change it anyway because I had some really nice Vichy ones. I think they're Vichy. Anyway, they're much better than the crap that was on there. And I also replaced the large electrolytic capacitor with a Panasonic FR series. You can sort of see that there. Definitely not fun changing electrolytics on a through-hole veered board. And I'm going to have to think about how I'm going to recap the rest of this board, because it's definitely very time consuming doing it the way I would normally do it with my iron and a solder sucker or braid. But yeah, that's been replaced and it's looking really good. But the Exxon cap that was removed was in good condition. Little low on capacity, but probably still good enough. And ESR was really good also. So yeah, we're done, I think. And we're going to find out if the smoke is going to come out of this board again. It's looking pretty good. Let's see what happens. I'll throw this board back in and let's cut to powering it up for the first time. All right, so I've got the board back in. It's temporarily just sitting there. I'm going to be just careful around that, of course. Let's turn on the power, see what happens. Hopefully no magic smoke, and I guess we'll probably get a light. I never even actually looked at this thing. And I'll keep an eye on the power consumption here. And hopefully no fire. And here we go. Power. Come on, power. 3 watts. Okay, it's holding. Oh, lights on. Excellent. I think that means it's booting or pairing or doing something. We're up to 4 watts now. Okay, it's definitely doing something. So that big capacitor we changed, that was the bulk capacitor for whatever this regulator is doing, whatever voltage it is. So we'll have a quick look at that. 12 volts. Whoa, don't slip. So it is a 12 volt regulator. That's all that whole thing is doing. Yeah, so that's good to know for anyone at home. If you do not have 12 volts across that capacitor, then this area is not working. And that is looking good now because we had nothing across that capacitor before. Light has gone out, so I guess that means it's connected to my network. So let me just go and check on my Wi-Fi and see what's going on. All right, so I just checked on the Wi-Fi. It is on, and I just had a look in the Sonos app, and the sub is there. It actually had a firmware update waiting, which I just installed. That was a little scary considering this is not assembled yet, but I did it anyway. Seems fine. It's booted up. It's back on. It's probably been offline for quite a while, actually, because it seemed to have been removed from my lounge room setup also. But I'll show you a picture from the app that it's there. Everything's looking good. So yeah, this was a really long video. Way longer than I thought it would be, to be honest. But this is first time really doing surface mount work like this. So it is what it is. I've decided I really didn't want to do a third part to this, but I am going to do a third part. And we're going to recap, like change all the big capacitors, which should be relatively fast, or it's a simple job, but this board is not simple. And I have a very high-end desoldering station on the way already. It has shipped. I got notification today. So that should allow me to change these capacitors much faster, I hope. We'll see. So we'll do all the capacitors in the final video and then we'll reassemble it. But for anyone who wanted to see this thing working, it is working. It is on the network, and I've just got to connect it all back up, change those capacitors, and we're good to go. But those Cap Exxon capacitors, honestly, I think they're probably fine. But I've got this thing apart. I bought new capacitors already, and I've got a desoldering station on the way. So let's just change them while this thing is apart. So we'll come back and do that in the final video. Much success in this one. Hope you enjoyed it, and I will see you in the next video.